Astronomers typically define a habitable planet by its location. If it sits inside the Goldilocks zone, the precise orbital distance where liquid water can exist, it passes the first test for life. But orbital distance alone fails to explain why Earth is a flourishing blue marble, while its neighbor, Mars, remains a frozen wasteland despite sitting in that same habitable band. Location is only a starting point. Habitability requires a second internal component: planetary engines. To understand how these systems dictate the fate of a world, we have to look at the extinct geological fires buried beneath Mars and the highly active marine biology churning away right now on Earth. A habitable planet is a complex machine. It demands a constant supply of internal energy to keep its life support systems running. The Martian surface today is a landscape of frozen, irradiated rock. Evidence reveals this dead crust once concealed flowing magma rivers. This molten rock was a geothermal engine, radiating heat upward to melt subterranean ice. This water mixed with minerals, creating a nutrient-rich chemical soup deep beneath the surface. This combination of heat, water, and chemistry made ancient Mars a prime incubator for early life. But as the planet's core cooled, the heat faded. The magma rivers slowed to a halt and the rock solidified. Mars lost its habitability because its internal geological engine ran out of fuel and died. While the engines of Mars are made of stone, Earth's active, vibrant oceans are powered by a massive biological cycle. Our oceans operate as a continuous biogeochemical engine, driven by a process called the whale pump. The cycle begins when marine mammals dive to consume nutrient-dense prey in the dark abyssal ocean. Returning to the surface to breathe, they expel massive biological waste. This waste, loaded with iron and nitrogen, disperses into the sunlit ocean layer. It acts as fertilizer for phytoplankton, triggering rapidly multiplying green blooms. As these vast fields photosynthesize, they release continuous oxygen into the sky. This cycle generates approximately 50% of the atmospheric oxygen on Earth, meaning half the air we breathe is manufactured by mammalian digestion and marine microbes. Whether it is molten rock melting ice on Mars or deep-sea mammals fertilizing microbes on Earth, both planets rely on internal mechanical systems to remain habitable. These systems require a perfect chain reaction. Subterranean heat must meet ice, and deep-sea nutrients must reach the surface. A breathable atmosphere and liquid water are the temporary outputs of an active, ongoing metabolic process. Mars is a graveyard of a broken system, a look at what happens when the internal gears of a planet stop turning. Earth's biosphere is currently running, but its biological engine is vulnerable to disruption. Diminishing global whale populations tampers with the specific biological cycles that keep our own planetary life support system operational.